Hi everyone, I wanted to demonstrate a video on how to use the hypothesis test template. So let me show you where we are. We're in the course and we're in week 13. And the two files that you need to open are hypothesis test, and if you want to follow along with the example, it's week 13, module 23. Alright, so let me show you. I have these files set up behind me, or behind the screen here. Okay, so let me zoom in a little bit here on the actual problem. So here's one that was done in 2008. 17% of boys were told they had asthma. That's in 2008 in general in the United States. But a Florida researcher is concerned, so let's highlight this number, is concerned that there's a greater proportion of boys in the state of Florida may have asthma. In a recent sample of 100 boys, 22 responded that they had been told that they had asthma. At the 1% level of significance, right, can you conclude that the asthma among male youth in Florida is higher than the national figure? So there's two directions here. Both of these said higher. So this is higher and this is greater proportion. So we know that we're going to be doing something greater. All right, so let's state the null and the alternative. So the null hypothesis is the background condition. That's the 17% of all boys. So we're trying to see if that number is still true, or do we have new evidence to suggest that it is false. So we're going to do H sub 0, and we're going to call this P equals 0.17. That should be our 17%. Remember, this means 17% of boys in 2008 have asthma. I think I spelled that right. All right. And then the alternative hypothesis, according to this study in Florida, they believe that they have greater than 17%. All right. So in Florida, so this is my Florida data, so my new evidence. All right, so we're trying to see if this is statistically significant versus the 17%. All right, and how many do we have? We have 22 out of 100, so that's going to be about 22%. All right, so let's highlight that. Okay, next. Will you perform a left, right-tailed, or two-tailed test? So we are doing a right-tailed, and that's because we are looking at greater than. All right, so before we do the actual test, we have to make sure that NP is greater than or equal to 10. And that should be a lowercase n, but Microsoft Word likes to change that to an uppercase 10, or uppercase n. All right, so we have 100 is our n, times 0.17 is our p, and that equals 17. So yes for successes. All right, let's try the next one. All right, so that's 1 minus p. So if I do 100 times 1 minus 0.17, that's going to equal 83. And that would be yes for failures. Okay, so we have met the criteria for both the successes and the failures, so we can proceed with the investigation. So this is where I have to fill in my chart, which is above here in the Excel thing. So let's get the numbers that I need. So back to my original problem. The alpha level is the level of significance, and you can read in the problem here it says 1%, so we're going to do a 1% here. And then we can hit tab. X is the successes. So in this case, for my sample, the number of boys that responded yes to having asthma is 22. Obviously that wouldn't be a success in real life, but for this problem, we have to delineate what were the proportion or the variable of interest. All right, so sample size is n, so we say that's 100. So there's my p hat, 22%. The P is the population proportion. That's my null hypothesis. So the old number was 17%, so we can put in 17%. And remember, this is one-sided, so I would do a 1 and hit enter. Okay. Whoop, and I came down to the other one. All right, so let's see how close we are to statistical significance, or if Florida actually, their numbers are about the same. All right, so let's see what we have here. So what is the sample proportion? So P hat equals 0.22, which is 22% of the sample, of the random sample in Florida reported having asthma. Okay, so that's what my P hat is. So I actually do have more than the national average, but the question is that statistically significant, or does it fall within the realm of plausibility? Is the sample proportion consistent with the alternative? Yes, since my sample has a greater proportion than the population proportion. Alrighty. What is the mean and standard error of the distribution? I can't write the symbols, but the mean is going to be the mean of all the sampling distributions, and the mean should equal what we consider to be the null hypothesis, so 0.17. And that would equal, that comes from the null hypothesis. The standard error, which again is the standard deviations of all the sampling distribution, and that's a pretty ugly formula normally, is actually done right here for us. So that is 0.038. Okay, and let's just take a look then. Okay, can I highlight this? And let's take a look at what this distribution would look like. All right, so I'm going to go to my website here and take a look at the normal curve calculator. And let's put in the mean. That was 0.17. Standard deviation was 0.032. I don't remember, so let's go back to the number. It was 38. Yep. Okay, so I got to go back and fix that. All right, and then we hit enter. And here is our curve with the standard error built in. So my sample was 22%. All right, so if I shade this in for you, if I say above 0.22, you can see where that falls in this distribution. All right, so you can see that I'm 1 standard deviation, but then I'm not quite 2 standard deviations above the mean. And you can see that my p-value, or the probability of having a sample that extreme or more, is 9%. All right, so let's finish up the problem here and see how we would analyze those results. So what is the test statistic? That is ZTS is equal to, and again, that's another complicated formula, is 1.33, which basically means that my sample was 1.3 standard deviations away from the mean if the 17% is still true. What is the p-value? So the p-value is equal to 0.092, which is the probability of achieving a sample of this value or more extreme if the null hypothesis were true. So let's state a conclusion. So 9% is not, that common, but in statistics, and for this question, we need to fall below 1% chance. And over here on the right, you can see it's failed to reject. So what can we conclude? We fail to reject the null hypothesis that the proportion of boys with asthma is 17%. So we fail to reject that notion that the true proportion is 17%. We don't have enough evidence to reject it. What can you conclude about the alternative hypothesis? We do not have sufficient evidence that the alternative hypothesis is true, that the proportion of boys in Florida with asthma is greater than 17%. In other words, it's not statistically significant. Yes, we do have a sample that's greater than 17%, but we haven't been able to rule out random chance. And I did the context of this, interpret your decision. I think I did all of that already. Okay, so then the question number 5 just says, suppose that the level was now 10%. Would this level of significance affect your decision? Well, that's a pretty low level or high level of significance. And if I just change that to 10% right here, you can see that does actually impact my question. So, yes, this would impact my decision, and I would reject the null hypothesis. Okay, so that basically sums up how you use this template. Remember, what's important is that you do need to write the null and alternative hypothesis first, because that's part of the data that needs to be put into this template. The null hypothesis is the 17%. The alternative is the one that's the greater. All right, well, hopefully that helps you on your quiz and for some of the module checkpoint questions. And all right, good luck.